So, we've got a guy. His name is Dave. That's Dave. Okay? So, Dave's duty, he's on the deployment team we talked about before, and his duty is to, it includes standards enforcement. He's like the watchdog over our production environment. So, historically, Dave is engaged late in our deployment structure. Like I was talking before, we don't hear about a project till we get it in UAT. We're not enforcing standards we come up with. We're enforcing standards that are given to us from the architecture group, from the security group, stuff like that. So, but those groups don't do audits. They just set standards. So it falls to us to enforce their standards. Dave does random standards reviews for standards and rejects the manual deploys when found not to be compliant. So we can't watch everything. When we have time, when it's a slow spot, we'll take a look at what has been submitted to us and maybe take a deeper dive on it and take a look at it. But we have only a few people and we have a whole bunch of apps. So we can't go deep dive on everything. So, challenges are, we're caught late in the development cycle. We're now catching it when it goes to UAT. Teams could have been working on their stuff for months before we see it. And then we see it and we're like, hold on a second, you can't do that thing because we're not going to support it in production. We don't have the manpower to, or the data power to watch everything. We've got to pick and choose what we do so things slip through. That results in inconsistent messaging. We catch it the second time they do it. They go, well, we did it last time. We did it 2 months ago. What's changed? Well, nothing's changed. We just didn't catch it the first time. Now we're catching it. No, you can't do that, and go. So that results in, like we said, inconsistent messaging and miscommunication between us, between ops and development. As we said, that becomes an us versus them. Dave's rejecting my deploy because Dave's a jerk. He just doesn't like us. He doesn't like our team. We need someone else to look at this because the problem is Dave. So, we audit. Deployment, analysis, and verification engine. Davebot. Is that a little disclaimer on the bottom? All right. So what are the benefits? We integrate this in our automated pipelines in the build step in BuildMaster. So if we've pushed left, like we've talked about earlier, then we're catching it right at build before it's gone into their dev environment, before it's gone wherever. We're actually rejecting the build up front as soon as it comes out. And like I said, the better the team, the more of an early adopter they are, the earlier in their cycle we catch it. You can't argue with a script, right? You can't argue with a standard. Go ahead and try. It doesn't work. It's a piece of paper. It's a piece of code. So you end up, all the arguments about it's a person, it's a problem, it's whatever. No, it's just a script. We run this script. If it passes, you pass. If it fails, you fails. So the communication changes between you and the teams. We also use it as a communication method to communicate new standards. So we'll put in a section into Davebot of a new warning of something new that we're going to try to enforce. And the teams will start building that day and they'll start to see warnings and it'll come up, it'll still allow them to go ahead, but it just throws a warning, they see it in their logs and they go, oh, and the warning will say, this is a depreciated, we're no longer supporting blah, it is depreciated, we're going to start rejecting builds in a month, 2 months, 2 weeks, or whatever, if you keep doing this. They're still able to go ahead, but because they ignore our emails, it's another way to get their attention. So Davebot doesn't sleep. Davebot checks all the standards on every build. Everything that we've said we're going to check, we check on every build. Our auditors love Davebot. All of a sudden, things aren't sneaking through. We give them a list of the stuff that we're checking, and they go, oh yeah, okay, that's great, that's great, that's great. So we get a lot of positives from them. Okay, so Davebot's written in PowerShell. Just made an easier integration. Our whole plan all along, we had BuildMaster first. So our plan all along was to integrate with BuildMaster. That was the easiest way to integrate with BuildMaster. It's just housed as a series of global PowerShell scripts in BuildMaster. And it's part of our default build/package template. So if you are doing a simple web service, it just automatically gets included. It's automatically going to be there. So what do we have? We have separate scripts in Davebot for review of SQL, for file scans, for web config review, for assembly version review. I thought there's 5. Okay. Okay, so SQL review. Now we're diving deeper and deeper into this, so we're just going to get into some technical details. For SQL review, we use Microsoft.SQL Management.SQL parser. So what this allows us to do is check whether the SQL is valid without running it against anything. It just parses the SQL, and if the command is successful, you have good SQL. If the command is not successful, you don't have good SQL. So it allows us way before deploy, again, a build step, to do some validation on this. So the parser also, that's not all it does, it also tokenizes it, and it's a whole black art about how to interpret the output from it. But it tokenizes like operators versus operations, and so what allows us to dig into the details of SQL in a way that isn't, doing text search through the whole document. We're actually kind of working with it it's a tokenized output. So we validate the SQL, we parse it. Now what are we looking for? In general, we have two kinds of SQL that we allow in our environment. We allow DDL, like new stored procs data definition language, and we allow data fixes. They're run differently. I'll get into. I'm like, do I have to get into the details? I do. So data fix in particular, how it works is they submit it, and we tell them to do it as a transaction with a rollback. That's how they submit it. So our UAT step, our UAT environment is run that thing with rollback. We attach the output. Their business validates that script with the rollback. If the business approves, we run the same script, but we replace the rollback with a commit. So we end up with the ability to run this thing against prod, but still have an approval step. So data fixes are very specific, and we need a certain structure for them. Data definition language, although we allow on the other side, if you say I'm doing a data fix, we know you're only going to run against prod. So you're not going to be allowed to do any DDL in there. You can do, you're allowed to do updates, but you're not allowed to create new objects or any of that. So if this thing's marked as a data fix, you can't do any of that stuff. So if it isn't a data fix, then we're checking for all the other side of things. So these guys will use a use statement. What does that allow you to do? Well, it allows you to hop between databases on the same server. We're running as an admin account. We can't let you run on whatever random database you can guess the name of. If you're doing a data fix on database blah, that's the only place you are. So to prevent that, we just screen out use. If you come in and you give us a script and you have a use statement at the top, we're going to reject it out of hand just because you shouldn't have it. If you're trying to get to a different database, you should have a different pipeline that's specific to that database and do it that way. Grants and users are because we manage rights with a different process. It's not a deployment thing, it's a security thing. So you're not assigning rights within your scripts, you're just creating the objects. There's a different process that has different approvals for dealing with security. So here's the data fixes must contain a rollback, but can't contain a commit. So that's just so that our baked-in process can run it once and we know everything will roll back, and then we change a rollback to a commit when you run it the second time to actually change the data. So that's the SQL one. File scan. This is the file scan stuff, and we're getting kind of more and more, we're talking .NET specific, right? This is very specific to ASP.NET stuff. So file types that will result in a rejection of the build include PDBs, source, thumbs.db, temp, old, back. So PDBs are compiler information. They help you with debug. That's great. Good on you. Not UAT or prod. Same with source code. Just increases your attack surface. Security guys don't like it. If you include your source code, you're going to get rejected. Thumbs.db is one that gets us all the time. When you browse, right? In Windows, you browse to a folder. It creates a hidden file, hidden read-only file called thumbs.db. If they include that in their artifacts and then you try to deploy it and it's already there, it just craps out. So we're looking for that sort of stuff. Temp, old, and back are just to, again, keep the deployments as clean as possible. We also just check the whole thing for read-only files because we don't want to be changing attributes and mucking around with it. You shouldn't have a read-only file in your artifacts. If you do, when we copy it, it gets copied with the read-only. And then the next time you deploy, it fails, and you're like, what did you guys do? We didn't do anything. You gave us a read-only file, and now that's sitting on the server, so now we got to go in and muck around with the attributes to be able to copy over top it. That's the other one, secret reporting services. So we have a separate Davebot for secret reporting services. It's pretty straightforward, but some teams get real creative about what they want to put on a reporting server. So we just say, no, you can only put on stuff that makes sense to go on a reporting server. As well, when you're automating reporting services and you're trying to get the same thing to go between all environments, data sources become important. You want the same RDL, the same report definition in all your environments. You only want your data source to be pointing to a different place. So we standardize what the data sources are supposed to be named, and we check, and if you haven't got them named that, we reject the build. And then that way, the DBAs are just configuring the data sources on each environment, and then you just drop the RDLs and they automatically pick up the new data source. Davebot version scan. One of our standards, and this is partially from the auditors, is that when you compile your code, you have to have the version correct. The version that's compiled in your DLL needs to match the version all the way through your artifacts and everything else that's happened. So when you do a build, BuildMaster will have set up BuildMaster to look at one of your DLLs. We pull the file info from that and compare it to the version in BuildMaster. If the version in BuildMaster, not including the build, right, like 3.2 or whatever, depends on the application, on how far down we'll compare. If they don't match, we're going to reject your build. We're going to say, hey, you didn't update your version within your compile. We're not letting you put that DLL on the server with a different version than what BuildMaster says the version is. If we were more tightly coupled and we were actually running the build from BuildMaster, we could force it, but we're not. We're loosely coupled. I think finally, if I got my count right. Davebot web config scan. So we do the web configs and the configuration a little different. When you give a release to us, we ask for a configs folder. That configs folder has all your environments that you're going to deploy to and the web config associated with it. We originally were using the baked-in configuration repository within BuildMaster, but these guys changed their configs a lot, and it was becoming just a pain to constantly update it. So we just made it a deployment artifact. When they give it to us, we run a bunch of checks on those web configs, partially for just settings, partially specific to the environment they say that web config is going to. First off, debug equal true. UAT in prod, no debug equal true. In proc session state, so we use session server so that we have stateless .NET applications. If somebody submits it, a web config within proc, we reject it. One of the reasons that we want to catch this stuff early if we can, if we catch it by UAT, well, they've done, they haven't, they've gone a long way without having proper session state. Trace equal true. We're checking for non-internal email addresses. We have a lot of contractors. They like to send stuff to their phone or to their own stuff. And so we scan the web configs for emails that we don't want them to use. Otherwise, the auditors get mad at us. Unapproved file shares, the same sort of thing. There's certain places where we're allowed to put file shares, but we'll have developers who go, well, it's way easier if I put a logs folder on my workstation and then put that into the web config and submit it accordingly. Like, that's super easy. Yes, it is. It's not compliant. It will get rejected. Cross-environment database connections is specific to the way that we do the web configs, plus the way that we name our databases. So we know what a dev web config is supposed to look like, and we know what a dev connection string for the database is supposed to look like. So when, as part of the Davebot file scan, we look at those two things, and if you're trying to go to a UAT database from a dev web config, we're going to reject it. The other way is more likely, right? Is the bigger error where you have a prod application that's hooking up to a non-prod database. We're going to reject it. I just flew through that. So what I'll do is I'll just kind of show you a bit of the code. We won't go into the details, and I've just got a basic setup of an application so that I can show you it, but none of this is live. So script assets, PowerShell scripts. So this is what we just talked about. Here are the scripts themselves. Everything is variable driven. So if we take a look, we'll take a look at the SQL one. It's big and scary. So we've got a lot of different. Oh, I wonder if I'm going to have to kill this. Thinking. There we go. All right. So, sorry, I think I'm going to have to restart the game bar. It's specific. The only thing about this is that it's specific to an application, not to a screen. So every time you switch applications, you've got a. So we'll just take a look at the validate SQL as an example here. So we set up a bunch of global variables, and then we override those variables at either an application or a pipeline or an environment level to give you the ability to change the behavior, right? So that's kind of what you're seeing here. So we have default rule sets that stop if the parse, stop if there's a database statement or use statement, warn on select star, ignore if select star exists, and so on. And then messaging accordingly. And then the real secret sauce is here. So it took us a bit to get it working the way we wanted, but this is setting up that parser and executing it. So you can find the stuff on the interwebs about how to do it. It's not super hard, but when we found this was really quite golden to us, because we would get a lot of SQL statements that were just bad, that were missing a quote, missing a semicolon, missing whatever, and we didn't find it till we actually tried to execute it against production. And depending on how the SQL was written, it may have done some stuff before it actually fails. So then all of a sudden you're in a rollback situation and it's just painful. So this probably saved more round trips than any of the other ones, because this would actually cause failed deploys, where the other ones will cause security violations or other stuff that we don't want to see. So just in general, I mean, we end up with this is the Web Build Simple plan, which calls the module Web Build Simple. So if we go to the modules and we look at what that does, I don't want to buy you. It really wants me to buy. So, by default, we are doing a web config scan, we are doing a file scan. If the file, the DLL that you want to check is passed in, it checks that. If all of those succeed, then we create the artifacts. And this is used in, like I said, like most of our simple applications, we're using this sort of structure. So call all the compliance stuff, then create the artifacts if everything succeeds. And I mean, like I said, I was going down the failed path of trying to get this so I could run it. But just so you see, in general, that's what our build step looks like. So all we give it is a drop directory. Then everything else just works off of that drop directory, analyzes things accordingly, and just works. Then if you're special, there may be additional variables or other stuff that's visible in here for you to do more with, but this is the basics of that. I mean, each of these is very similar structure, so that we can easily add or remove checks based on there is going to be an exception. And we'd rather have somebody come into the automation than reject them outright because they have some Gmail address that has been approved by the security people to send logging files to. We're not going to say, well, no, you're not a good candidate for automation. We're going to say, okay, we'll document it and we'll override it. So everything that we have as a check also has the ability to override it. That's about it.
How does the actual report, like at the bottom of the script,
Right.
like how does the script actually work?
Magic. So the output is all done through write log, and then using write error, write warning, write inform will say whether or not the script is interpreted by BuildMaster as successful or not. And so we're outputting in the log what's happening, but by using write error, write warning, or write inform, that's what triggers BuildMaster to say, whoa, okay, this is a warning, shows up as yellow in the log, and the teams know, okay, yellow, I better read, but it's not going to stop me. Warning comes up as red as the log, stops execution immediately, and they've got to deal with it before they go on. Is that what you were wondering?
Yeah. So basically, just because you're writing a error state, BuildMaster will pick up red, and then you have it configured to just fail execution, or it automatically does that, and then you use the warn feature in BuildMaster to give that visibility. So it's okay. So it's not like developers have to parse some.
No, it's your logs. It's a BuildMaster log. The BuildMaster log gives them everything that they need, right? So it's all there, and so like the checks are there and whatever else. So like we'll find, like, we're in more verbose in some cases than others. So we'll find we'll find an email. We say, oh, we found this email. It's okay, right? Oh, we found this email. It's not okay, right? So we over time have given them more and more information. We've also taken this and wrapped it in a web service and made it available for them to check it even without doing a build. So they're like, we really like to be able to check our web configs without actually creating a build, because we're like, when they're first starting a new application, they'd rather just be able to submit it, right? Same as SQL. We'd rather not have a failed build. We'd rather check it. So we've wrapped it all into a web config as well, a web service, and so they can submit the artifacts to the web service, and the web service will provide it directly. We're playing with the idea of using that as the primary interface. So instead of having the PowerShell and PowerShell scripts here, have calls to the web service. Still do everything the same way. It's just run it as a web service on another server instead of PowerShell script. It just allows us to maintain a single code base. Right now, we're having to kind of do it twice, once for the web service and once for here, but it's not that hard.
It sounds like the rules are the hard part. The code is not as easier.
Yeah, and I mean, we just did for example, the Microsoft Dynamics, right? And we don't have a lot of the Davebot rules in there. We're probably going to end up with them, but it's so different, the way it's all kind of built up, that we don't really know what we're going to run into. So we're working with the Dynamics team to say, okay, well, we can do checks. So you just tell us what to check. And they're like, well, we'll get back to you. But almost everything that is in this version of Davebot was part of the manual processes that these guys would go through, or errors that they would hit, right? The invalid SQL was just a pain in everybody's butt. But the use statement in a database, or the grant rights, those are stuff that they would have to check for, and if they missed it, it would actually happen in prod, and then calamity ensues.
Is that how you built up the standards? Was by just over time, just having this internal knowledge base? Because like the rules list that you had there's a lot of rules, like all the SQL ones. It's like, oh yeah, you shouldn't allow reuse. Yeah. I assume someone broke that rule.
Oh, for sure. Yeah, and I mean, it's also we have similar stuff with config versus deploy. So at one point, part of the reason that we do Xcopy deploy and do the stuff the way that we do is because at one point we said to teams, oh, just give us a PowerShell script. All right, we'll just run a PowerShell script. We went back and audited that. We had file shares all over the place on these servers, and we had people granting rights, like local admin type rights and other rights on the server in the PowerShell script, right? And we ran it. We also had, like before we had these things, we had teams that would submit a SQL statement that would create a user, grant it rights, do all this stuff. Auditor comes in and goes, who did it? Well, we look through the logs, and it was one of the DBAs. And the DBA goes, I didn't do anything. He ran the script, right? So auditor doesn't care that somebody else gave you the script. Auditor says, you ran the script. This is your responsibility. So exactly, like most of these, like the PDB stuff and the source code and that kind of thing, that's more kind of industry or direction from the architecture group or stuff like that, where they said, we want to move in this direction, and we're like, how badly? Because we can just stop it right now. We just add that in to the checks that we have in place, and it will not happen. The in-proc session state is another one where in disaster, like we've got multiple data centers, one goes down, right? How easily an application fails over is tied directly to how sessionless it is. So if they're all in proc on one server, and that's the server that goes down, it's gone. They'll fail, although we have all the infrastructure in place to properly fail over, it's not going to do a good job of it. It's just gonna die, so. All right, anything else, guys? Oh, this gentleman in the front here, your name was Alex?
Very inquisitive, yeah. So, actually, we for a brief time to sort of experiments with different tool sets, try different things as we were changing our extension. But long story short, we started using AppFair to build our extensions. So we had dozens of extensions, and as I was noting here, I thought, boy, we really could have used Davebot for versioning, because that problem of not having the number match in BuildMaster, our rule was just edit the file in source control, your assembly info.
Yes.
Let AppFair build it, but so I thought that was interesting, but that got me thinking, what do your developers think of, like, do they hate the rules? Do they not care about the rules? Do they, like, when they're like, because I guess what you're doing is you're preventing them from adding backdoors.
Yeah. I mean, it is like Dave's a jerk is really, that's your answer. When we have the manual process, they see it as you slowing them down. We told the business we were going to release on Wednesday, and you're telling me that I can't do this build because of some weird whatever? No, we're going, right? So, yeah, there's going to be friction, right? As soon as you slow people down, they don't like it. But this allows us to do it in a way that we don't hear about it as much. So I'm sure they grumble, and we do get random emails going, oh, what the heck, why, blah, blah, blah. But we've got pretty good messaging in there, so the good teams look at the message and go, oh, I forgot, as part of our build, we used to have something that removed the PDBs. We're not removing the PDBs, so we'll now just add that stat back in, we understand, and away we go. So them being in the environment we're in, it's not necessarily a surprise. They don't love it, but some of the stuff, like if we catch a cross-environment data connection, that's stopping themselves from shooting themselves in the foot. That's stopping them from making a big mistake. And so I know that they're not going to complain about that stuff. But some of the other stuff, sure, I mean, it's like, well, I'm using the same database I'm running in. Why do you care whether I have a use, right? Look what I'm using. I'm just using this database. Yes, I understand. It's just easier for the checker just to say no uses, not check a use and it's there. Oh, but maybe it's a variable, and now you're changing the variable name and you're in a different database. No, we're just no uses. And then we're sure that you're not going to get silly on this. But yeah, it's, it is, and especially with the move towards agile and the move towards faster cadence. Anything that you do that slows people down can be seen as, well, you're not agile, you're not, this is a legacy way of thinking about it. We'll take responsibility, just let us do that. We're not in that kind of environment. It doesn't matter that a contractor who has a 2-month contract is saying that he's taking responsibility. He's gone in 2 months. We have to protect the enterprise as a whole, right?
Thank you.
All right?
Thank you.
All right, that's good.